Hello everyone, we are group 11. Today we're gonna have a presentation about our project topic in the course Operation Research. Our presentation will divide it into 6 parts, and there are 3 main parts, which are mathematical model, lingo application, and sensitive analysis. My name is Nhi, and I'm gonna start with the first part. As you know, network models are developing in various settings in real life that we can easily recognize, like transportation or electrical network. It describes the relationship between each of the components of the system. Additionally, in operation research, it's getting attention from various specialists in this field. In the context of logistics and supply chain management, transportation and delivery is one of the main functions of material consumption. To fulfill the customer demand as soon as possible, the problem of finding out the shortest path is required to be solved. In this project, our group will provide the solution of shortest path problem by Lingo software and apply the knowledge from the course Operation Research. My teammate Wing will continue with the next part.
My name is Nguyễn Thị Thanh Quyên, who's the next presenter. Now let's move on to the second main part, the problem statement. Linear programming has a variety of applications in fields of study. It is widely used in mathematics and to a lesser extent in business, and for some engineering problems. Industries that use linear programming models include transportation, energy, telecommunications, and manufacturing. Our group's assigned problem 7 is one of the most common types of applications of linear programming in the manufacturing industry, which is to minimize the distance and minimize the cost of delivery. Our objective is to minimize the distance from the A fulfillment center to the 9 towns and back to A and minimize cost of delivery. Next part will be presented by Nhật.
Okay, my name is Nhật and I will move on with the third part is mathematical model, and we will have 3 points. First is parameter. Firstly, to make our problem become more simple, we will change the name of delivery center in city ABCD F G H I J to number 1 to 10, and this you can see from this table that is the distance between the city to another city. However, there are some blank. For example, from A to F, there's no value in this box because there is no direct route from the city A to city F, and we must go. And if we want to go from A to F, we must go through the city B, and we must choose the value for this in the beginning of the problem. In this project, the objective is to find the shortest way to travel through all of the city. So those blank values should be displayed by a very large number. We can choose 1,000 or 1,000,000 in order to formulate a function in the lingo. In this case, our group decided to choose a value 100. This method is nearly the same with the big N method we have learned to solve the simplex, and 100 is big enough to make sure that each ij correspond is 0 to 0, and we have the new distance matrix. Okay, let's move on with the decision variable. In our problem, there is only one variable, is ij, and I from 1 to 10, j from 1 to 10, and this is the binary which is show the root will be choose or not. If it's ij equal to 1, we will move from the city I to city j. If not, we will not true that root. And next is the objective function and constraint. The objective of our problem is minimize the total distance. So we have the objective function is equal to the distance from I to j multiplied with the hij. Next is the constraint. We will have three constraints. First, the truck will go to only one city, so the total hij in the one row here is equal to 1. For example, if the row is from A to E, it means H15 is equal to 1 and another H1j is equal to 0. The same way with other 9 cities, and we will have 10 constraint rows. The second, the truck will move from only one city to city j, so the constraint of hij in one column is equal to 1. For example, if the truck move from C to D, it means h35 is equal to 1 and another hi5 is equal to 0. And the final constraint is if the truck move from city I to city j, it will not go back from CTJ to CTI. So we have the constraint is that Hij plus Xji smaller or equal to 1. Next, we'll move on with the Lingo application. We will use Lingo to solve our problem. It will faster than solve by hand. First is the objective. We will have the mean of the distance multiplied with the hij. We will have 100 number. The second is the total hij in one row is equal to 1, and we have 10 rows. The same, we have the total hij in one column is equal to 1, and we have 10 columns. And finally is the hij plus xji smaller or equal to 1, and we have 45 constraints here. That is the end of the Lingo program. And after using Lingo, we have the solution here. You can see that from the screen. We have variable h1a, 210, 34, 41, h52, h65, h76, h89, h97, and h103 is equal to 1. It means we have two solutions for this problem. We will start from 1 to 8 to 9 to 7 to 6 to 5 to 2 to 10 to 3 to 4 to 1, or we will move from 1 to 4 to 3 to 10 to 2 to 5 to 6 to 7 to 9 to 8 to 1. And final solution for the problem is that the root from city A to city H, I, G, F, E, B, J, C, D, H, or A, D, C, G, B, E, F, G, I, H, A. And the shortest root of our problem is 140. Next will be the next part will be presented by Tang.
Next slide. Okay. So hello everyone. My name is Tang, and today I'm gonna show you the sensitivity analysis of the problem 7. So there are three main parts in my presentation. The first is the analysis on allowable ranges of objective coefficients, and right hand side to say optimal. So the allowable increase or decrease is the amount by which you can increase or decrease the coefficient of the objective function without causing the optimal basis to change. So after using Lingo, we have the result, and so the result is really long with nearly 100 lines. So I just take some of these to illustrate to you. So we can easily see that x12 can vary in the range 18 to 20, and we still have the same set of basic variables comprising the BFS as which the optimum occurs. So The second part is about the reduced cost. The opportunity of reduced cost of a given decision variables can be interpreted as the rate at which the value of objective function, for example profit, will deteriorate for each unit change in the optimized value of the decision variables with all the other data held fixed. So let's take x11 for an example. So we can see that x11 has a reduced cost of 80. So the objective function should increase by 80 units in the maximization problem or decrease by 80 units in the minimization problem to become an attractive alternative. And we should note that if the reduced cost is zero, that is a variable included in the optimal solution, or we can say the basic variable. If the variable is not included in the optimal solution, non-basic variable, the reduced cost is different from zero. And the final part is the analysis on dual price or shadow price. So when on right hand side of a constraint grow by 1 unit, the shadow price is the amount by which z improve. Furthermore, positive shadow price raise the value of z in maximizing problem, but a positive shadow price decrease value of z in the minimization problem. And that's the end of my presentation. Thái will continue with the last part.
Hello everyone, my name is Thái and I will present the application in real life and conclusions. The optimization is essential in the production and supply chains as it will make other activity operate more smoothly and more efficiently, which can affect the development of or a business in the future. Next slide. This project is an example of the vehicle routing problem, VRP, which is one of the complex optimization in operation and management of transport, distribution, and logistics. The goal is to find optimal routes for multiple means of transport for a set of pickups and delivery. As you can see, the picture here is the Grab platform with the algorithm to optimize the destination for the driver with the shortest path. Next slide. Therefore, VRP is very important in processing and optimizing in business, which rates benefit. First is minimize the total distance traveled by vehicles. Second is minimize the total operating cost. And lastly is reduce the number of truck orders. Next slide. For the conclusions, the potential of linear programming for logistics is enormous. By creating a network between the nodes and calculating the shortest and the cheapest solution, the significant application of Lingo by carrying a large amount of data can easily solve. In the other words, solving the VRP aims to benefit the business by reducing costs and increasing efficiency. And that's the end of our presentation. Thank you for listening.